lecture number 19, which covers subsection 7.3.2. In today's lecture, we are going to study the second kind of the shifting. So translation on the t-axis. In the previous lecture, we studied the translation on the s-axis. First of all, let me remind you what we studied from the beginning of Laplace transform. So if I have a function f of t, and I need to find its Laplace transform with this notation. So it's given to be integral from 0 to infinity e to the negative st times my function f of t dt. And by the way, the same, so I call this one, I call this one f of s. Am I right? Also, if you have a function L of f of v, no problem. It's an integral, the bracket integral infinity e to the negative s of v f of v dv is given to be f of s. Notice now, if you used instead of this s, if you used z, so let me call it z. So it is f of z. Here, z, it is f of z. So don't worry about those letters, okay? After that, we studied some famous functions, how to find their Laplace and inverse Laplace for those functions. So we have two tables. Then we move to find the Laplace of the derivative of my function. So if I have y prime, the derivative, it is sy capital minus y of 0. And if I need to find the Laplace transform of second derivative, is given to be s squared y capital minus sy small of 0 minus y prime of 0. All those we studied, and we used those two rules to solve some initial value problems. Then yesterday, we studied the first translation theorem, which is on the s-axis. And if you remember, the first shifting theorem is given to be as the following. If you need to find, and by the way, the first shifting theorem will help me to find the Laplace transform of a product between two functions. One of them must be the exponential. So now I have a product between two functions. One of them, it is my function f of t, and the second one must be exponential, e to the negative, e to the at. E to the at. Okay, is it clear? So Laplace product, Laplace transform of a product e to the at times f of t is given to be Laplace of my function f of t, and don't care about the exponential, but you need to shift your s into s minus a, and this can be written the same can be written as f of s after shifting the s into s minus a. Or you can write it as f of s minus a. And we studied the inverse of this formula. So if you need to find Laplace inverse of fs minus a, it isn't fs, it is fs minus a. So I need to use the first shifting theorem. It is e to the at times f of t. The a is written here, and f, this one, the f of t. Can any one of you tell me what is the relation between f small and f capital? So if you have f capital, how to find f small?
Laplace inverse.
Laplace inverse, great Islam. Laplace inverse of f of s. Notice here, I will give you f of s minus a. You have to guess f of s, then find its inverse to find your f small, then multiply it by the exponential. Those we studied in the previous lecture, and now let us start the new ideas. Here are the objectives. Now, before we start our new theorem, let us introduce the concept of unit step function. This is the unit step function. I can notice now from this figure that the unit step function has two different values. Maybe 0 if the t less than a, and also the unit step function may be 1 if the t greater than a. And this is a 1. So the unit step function, it is a piecewise continuous function. its definition or its notation, u of t minus a, this a. And this ut minus a, which is the unit step function, or we call it Heaviside step function, it's very important for the engineering students, has two different values, 0 or 1. 0 when your t less than a. And by the way, I can write this in another way. If I moved a here, so it will be t minus a less than 0. And also, it's the value of my unit step is 1 when my t is greater than 1, t greater than a. I can move a here, so my t minus a must be positive number. So for me, starting from now, the unit step function, if I have this variable less than 0, so the answer is 0. But if this variable is greater than 0, so the value of my function is 1. And now he asked me to find Laplace transform of this function. Let us together try to find Laplace in the coming slide for this function. Give me 1 minute just. Yeah. So here, using the yellow, I need to find the Laplace transform of ut minus a. Don't forget the definition of this unit step function is given by the following. I remember that u of t minus a is given to be 0 or 1. 0 when my t less than a and greater than 0, and 1 when my t greater than a. Yes. Who can help to find the Laplace transform of this function? What do you think? How to find Laplace of this function?
It would be integral from 0 to a.
Great. The definition of Laplace transform, integral from 0 to infinity. So first of all, let me write in details from 0 to a, e to the negative st times u of t minus a times dt. Now my u has two different values, and those values depending on my interval. So I'm going to write my integral as a summation between two integrals. So integral from 0 to a, first interval, e to the negative st times my u in the first interval from 0 to a. Your u is what?
0.
0 dt plus the second interval from a to infinity, my exponential st times my u in the second interval when my t greater than a is 1 dt. This one is 0, cancel out. So I have only this integral. So it's 0 plus negative 1 over s e to the negative st from 0 to infinity. Don't forget you need your s to be greater than 0 to get the convergence integral. So I have negative 1 over s. When my t is infinity, so I have e to the negative
Doctor,
infinity. Which, yes.
is it from A to infinity?
Yeah, it is. Here a and here a. Okay, so when my my t is infinity, so I have e to the negative infinity, it is 0. Now my a, so I have negative e to the negative sa. Now minus and minus, those will be plus. I have e to the negative as divided by s. So you can add to your cheat sheet that the Laplace transform of this unit step function is given by this formula, e to the negative as divided by s. It's a rule, and it is very important. Now, I need you to help me to find Laplace transform of this function. No need to graph it. I need to find its Laplace transform. Who can help now? So I need to find Laplace of this function. How to find Laplace of this function? Notice, first of all, you have a product here. Actually, we studied in the previous lecture the one rule for the product between two functions, but one of them must be the exponential. Now I don't have an exponential, so I can't apply a rule which we studied in the previous lecture. So what should I do now? Guess, please. So if you can't do anything and I ask you to find Laplace transform, what should you do now to find Laplace transform?
Integrate.
An integral. Yes, integral from 0 to infinity of my function t minus 1 squared times u of t minus 1 times the exponential negative st dt. Now this u has two different values. Maybe 0, so ut minus 1, don't forget it. Maybe 0 or 1. 0 when your t less than 1, and 1 when your t greater than 1. So how to continue? What should I do?
Separate the integral into two.
From 0 to 1
Yes.
of my function t minus 1 squared times 0 exponential and plus integral from 1 to infinity t minus 1 squared times 1 times exponential st dt. This one cancel out. How to find this integral? How to integrate this function now? It's a polynomial times exponential. Do you remember?
We will expand the polynomial and then apply e for negative st with each term, and we will integrate.
Yes. How to integrate those three terms? The first one I need, which is t squared times e to the negative st.
We will integrate by parts
Twice. And you need to integrate the t also one time by parts. So you need to apply integration by parts 3 times. Maybe you need 9 minutes. Am I right? To find the final answer, you can do that in the exam and get full mark. For me, I'm going to study a new technique which can solve this problem in only 1 or 2 minutes. Okay, look what I'm going to prove now, the following theorem. And this theorem called second translation theorem. The theorem is the following. If you have a function f of t and its Laplace transform f capital, you know this, and you need to find Laplace transform of this product between two functions. One of them the unit step function, and the second one it is the same of your f, but after shifting it. The answer, which we are going to prove also, is given by this formula. The exponential negative, notice in the previous lecture no negative, for t times fs. What I mean by fs, it is Laplace of this. Now, when students will ask, Professor, I don't understand this formula. What do you mean by ft minus a, ft minus a? What do you mean by this? Let me give you an example. Let us consider our f of t, it is only sine of t. What do I mean by f of t minus a? Let me write here plus t squared to make the problem easy, more difficult. So I'm going to replace each one of my t by t minus a. So it is sine t minus a plus t minus a all squared. So ft minus a, it isn't difficult, only replace t by t. Let me prove the theorem, then we will solve this. So in the coming slide, I'm going. Sorry, but what I need to explain also here, this formula. Also, it's a rule. And by the way, we proved this in the previous slide, that Laplace of the unit step is given by this fraction. Now I need one of you to help me to check, can I find this formula from this? Is it a special case? This one, is it a special case of this? What do you think? Here you need the unit, so here you have the unit, but unfortunately no function. What that mean?
T equals a plus 1.
Repeat.
T equals a plus 1.
T equal a plus 1. If t, no, I didn't understand. Could you please repeat again?
لا يبقى f of t minus 1
Yes.
equals 1 اللي هي d equals 1
Hey,
يعني.
so you I understand now. David suggests, please, Professor, this function deal with it as a 1, because here I have the u multiplied by 1. So I'm going to apply this rule. The rule said, please write f of write e to the negative as. I wrote it here. Write fs. What do I mean by f capital of s? It is Laplace transform of my function if small. And now David, in this special case, said my f it is 1. And Laplace of 1, I have it in my cheat sheet, it is 1 over s. So here, I'm going to multiply this by 1 over s, so it is the same rule. Is it clear? Now I'm going to prove the theorem. Here, let us prove it. Maybe in the exam, I will ask to do that. Prove the formula. So here is proof. Together, always if you have left hand side and right hand side, maybe you will start from the left hand side to get the right hand side. I'm going to start from the left hand side. That will give me, I need to find Laplace of f of t minus a times u of t minus a. How to find this formula? Till now, I don't know, but what I know, the definition of the unit step function. Let me write the definition of the unit step function here. Here. So the unit step function, u of t minus a, is given, don't forget, it is 0 or 1. 0 when u or t less than a, and when t greater than a, I'm so sorry, a, this is a. It isn't 0, this is a, and here greater than 0. So what do you think now should I do? Who can help now to find the Laplace transform of this? I'm so sorry because I used the zoom bin. So here the proof. So I'm going to find left hand side, which is Laplace of this function, f of t minus, sorry again, I need to use the bin of, so here left hand side is given to be Laplace. Yeah, now who need to speak of t minus a? How to find the Laplace of this product? How to find the Laplace of this product?
By integrating.
Integration, yes. So equal integral from 0 to infinity. E times e to the negative st times my function f of t minus a times u t minus a dt. Now you have two different values for this function, 0 or 1. So I'm going to separate my integral into two integrals from 0 to a, the same function, e to the negative st times f of t minus a, okay, times 0 dt, plus the integral from a into infinity e to the negative st f of t minus a times 1, because my ut now it's 1 dt. Yeah, for me the first one is 0, don't worry, because here you have 0. What should I do for the second one? For me, I'm not familiar to find an integration with f of this difference. So I'm going to use this substitution. Let t minus a, maybe v, equal v. So the t, it is v plus a. So dt, it is dv. And when my t equal a, that will give me, my v is what? If t is a, so v is 0. And also when my t tends to infinity, that will give me, if the t tends to infinity, the v will tend to where? So t infinity, infinity minus a, it's infinity. So I used this substitution to integrate the second one. So integral, instead of a, you have 0. Infinity, it is infinity. E to the negative s, instead of t, you have v plus a. F of t minus a, it is v, times dt, which is dv. Am I right here? I think it's clear. Now what I'm going to do, only to multiply this is here. So what I have now, integral from 0 to infinity, e to the negative sv times e to the negative sa. Am I right by this product times f of v. Am I right here? What do you think? Now this one, I think it is constant. Am I right? Because your integration with respect to v. So I'm going to take it out, e to the negative sa, integral e to the negative sv f of v dv equal e to the negative sa. What about of this last integral? Last integral. This one. What do you think about this integral? Don't forget it is from 0 to infinity. Who can tell me what is the answer of this integral?
f of s.
F of s, great, Mahmoud. Yes, this one it is f of s. Because f of s it is the Laplace transform which is given to be integral 0 infinity e to the negative. Don't worry about t or nothing. What I need here to check if this v like this, like this. So my answer it is f of s. So now I found the right-hand side. I found the right-hand side equal right-hand side. So I proved. Please add this rule to your cheat sheet. Any question about the proof? So let us go now to take the alternative formula for this rule. The alternative formula for this rule. Notice now, here you have the product between unit step and shifting of your f. So you get exponential negative times f of s. Don't forget that this of s, it is Laplace of f of t. Don't forget that. Now the alternative formula, if you have the same u, but instead of t minus a, you have gt with no shifting. So you will write the exponential, and here you need to write the shifting for your g. Here no shifting because you have the shifting here. If you don't have shifting here, you have to do the shifting here. I think this one is more important than this. I'm going to use this a lot to solve problems. Is it clear? Let me solve one problem now. But before that, maybe we need to learn how to write a function using the unit step function. My question now, I need to find Laplace transform of this function. Who can help? Yes, Laplace of ft. Don't try it because those steps, I'm trying to let you know that you can solve in your exam one problem using more than 2 or 3 different methods. But one of them will be the best one and will save my time. So now together, let us discuss how to find Laplace of this function. We need to help. Speak, please.
We will integrate from 0 to infinity.
From 0 to infinity, e to the negative st times f of t dt. Then
we will divide it from 0 to 0 to 1 معلش.
0, because here you have the 1, okay? From 0 to 1 e to the negative st times first time times what?
dt.
T dt. And the second integral, it will be from 1 into infinity e to the negative st times 2 minus t dt. How to integrate those two functions? This and this. If you have a product between exponential and polynomial, so
By parts.
by parts, okay? Maybe you need 7 minutes to do those two integrals. Instead of spend 7 minutes, I can find Laplace transform of this function maybe in 2 minutes. How to do that? I'm going to learn how to write any piecewise function like this one using the unit step function depending in this rule. So here down, I'm going to introduce or to let you know the rule which will help you to write a piecewise function which is written in two formulas using one formula depending on the unit step function. So you will take the g from here, the same g, multiply it, and the h from this, and multiply it by unit step function. Okay, let us try now really to find Laplace transform of this function using this formula. Actually, this formula isn't Laplace, but this formula make my function has only one form. Then maybe it will be easy for me to find its Laplace transform here. So, but sorry, I'm going to choose one to help. Ahmed Atif. Ahmed here?
Yes, okay.
Yes, Ahmed. Now what I'm going to do to compare my function here with this formula. Okay? Could you please tell me the GT is what? Depending on the
T.
formula. It's
GT is
great.
T.
And what about h of t?
2 minus T.
2 minus t. And what do you think about your a?
1.
1. Great. Now I'm going to apply the rule. The rule said, here the solution. Yes, help me, Ahmed. So the rule said the f of t, it will be as the following. First of all, g of t. Please read here the formula. Yeah, gt, it is what?
Okay. T minus T.
T minus t times.
T.
Okay.
U T minus 1.
Great. Plus.
Plus 2 minus T.
2 minus t. Great.
Times U T minus 1.
Great. Thank you, Ahmed. Any question here?
Yeah.
Is it clear how to change the form of your function from the piecewise form into function using unit step function? I think it's clear. Now let me multiply this here and here. So I can write here, it is t minus tu of t minus 1. So here u of t minus 1 isn't a product, plus 2 times u of t minus 1 minus t times u of t minus 1. This term, it is similar to this, am I right? So I have two of them. So f of t now is given to be t minus 2 t u of t minus 1 plus 2 times u of t minus 1. Now I need you to find Laplace of this function. So you will write Laplace, that will give me Laplace of f of t is given to be Laplace of t minus 2 Laplace of this product, t times u of t minus 1 plus 2 Laplace of u of t minus 1. Now, I'm going to find Laplace for each one of those. Can I find here the Laplace of this product? How to do that? I'm going to check. Let me find the Laplace of t. But I'm going to ask, I'm sorry, Basil. Basil here? Could you please help Basil? Yes, Laplace. Yes, Basil. Do you remember the Laplace of t, or do you have your cheat sheet?
So it would be n factorial of 1, which is 1,
Great. Over
s of s squared.
S squared. Great. Negative 2. Also, I need you, maybe I'm going to speak and you have to tell me right or wrong. Laplace of this product. Can I write Laplace of the first time Laplace of the second, or no?
No, I'd have to expand the brackets.
Where is the bracket? Actually, for me, I can't see any bracket here.
No brackets.
No brackets here.
I'm not sure, doctor, what I should do.
Let me tell you, we studied today the following rule. Laplace of g of t, I'm going to write the rule here, times unit step of t minus a is given to be exponential negative as times Laplace of g of t z plus a. This our today rule. Now, to help me, Basil, only I need you to tell me your g and your a and your gt plus a. So I'm going to write them here. The gt for this, what do you think? Let me write it here. Where is your gt, Basil?
Okay, so the GT is T,
Great.
negative 2T, doesn't matter.
No, negative 2 is a constant outside of Laplace transform, so
Okay.
don't care about it. Yes, it's a constant. So from this, I need you to tell me your gt plus. Here, notice you had your. So first of all, where is your a? Where is your a?
The A is 1. The
A is 1. Yes. So t plus 1.
plus 1.
Yes. So your gt, it is t. What about of your gt plus 1?
My GT plus 1
Yes.
is T plus 1.
T plus 1? Yes, you are right. You are right. So now I'm going to apply the rule here. Let me go back to yellow and apply the rule. The rule said you need to multiply by the exponential. So it is e. So here the product e to the negative 1s times Laplace of your gt plus 1, which you said it is t plus 1. Is it clear here? Any question? Plus the 2 Laplace of the unit step function is given. I will find it from my cheat sheet. It is e to the negative st, e to the negative as, sorry, and my a is 1 times s. So it's e to the negative s divided by s. Okay? Now this one. So our problem now is to find e to the negative as times this. Basil, how to find Laplace of this? Laplace of t plus 1. What do you think? Abdurrahman Muhammad.
Yes, doctor. هنعمل Laplace of t plus Laplace of 1.
Yes, you are right. Laplace of t, great. Laplace of t plus Laplace of 1. Excellent. Plus 2e to the negative s divided s. Now equal 1 over s squared. So here the rules. Here the rules. E to the negative s squared minus 2e to the s. It is negative s. Laplace of t, as Basil said, it is 1 over s squared. Plus Laplace of 1, it is 1 over s. Plus 2e to the negative s over s. Maybe I spent 5 minutes to do that, but because it's the first time to solve the problem. So for me, I tried to find Laplace using the integration and using this rule. This rule saved maybe 3 minutes.
دكتور أنا بس عندي سؤال.
Yes.
أنا بس I don't understand how we opened the first line إن إزاي فتحنا brackets.
Yes, I go back here. So your question now, how I multiply. Notice first of all the u of, so this is part of your u. Okay, this is part of your u. It isn't a bracket. Okay, but now all those are one function. All those are one function. I will multiply them by the first term here and the second term. Or do you want me to go back from where I get this?
لا أنا كنت بس بسأل يعني multiply إيه بإيه بس خلاص فهمت.
Yes.
Thank you doctor.
Yeah. So u of t minus 1, it isn't a product. This u of t minus 1. This one, it is the same of gt plus a. It's a function, but the variable, it's the summation between two things. Other questions? So let us solve more problem and see the inverse of this formula. Here the inverse. The inverse of the second shifting theorem. Second shifting theorem. So if you remember that I have two formula. Laplace of f of t minus a times of u t minus a is given in my cheat sheet. I wrote e to the negative as times Laplace transform of f of t, or f capital of s. You are free. Take inverse here and inverse here. You will cancel this with this. So you have this formula. Laplace of e to the negative as times fs, which is the Laplace, equal this one. The alternative formula, if you remember, Laplace transform of g of t times the unit step function. So in today's lecture, don't forget that we studied how to find the Laplace transform of a product between two functions. One of them, it is the unit step function. So this one is given e to the negative as times Laplace transform of gt plus a. Take inverse for both sides. So here Laplace inverse and here Laplace inverse of this function. You will cancel out this L minus 1. So you have gt times ut minus a is equal to Laplace inverse of this expression. Let us use this one to solve some initial value problems. So in the coming slide here, I'm going to solve some initial value problems. This one. I have only question now. Forget please Laplace transform. Can you solve this problem? Find the solution of this initial value problem? Who can remember? By the way, it's very easy for all of you. How to solve this?
First order linear.
First order linear, yes. We did similar to this, I think, twice. You will solve first of all for sine t, then you will solve for 0. And you need to check to say that your function is continuous and so on. I'm not going to solve it as a first linear, but I need to solve it as, using Laplace transform. Here the initial condition. Please write your names first. Write your names, please. And let us together try to find the Laplace transform, to find the solution of this initial value problem. What do we think? Do you remember the steps for finding Laplace, for solving the initial value problem using Laplace transform? Do you remember the steps? What do you think? Do you remember the steps? How to solve initial value problem using Laplace transform? No one of you remember?
We first have it as a function يعني بتبقى مكتوبة كلها جنب بعضها f of t or.
Yes. But for me, Selma, I'm asking about first step to solve differential equation using Laplace transform. For me, I remember first step is to take Laplace for all terms.
Yes.
Now, my difficulty is how to find Laplace of the right-hand side. You suggest, Professor, you can use this rule to write your function, the right-hand side, as one expression. So I'm going to do that. Can I, Professor, now one student asks, can I find Laplace transform of the right-hand side using the integration formula and I'm going to separate my integral into two integrals? Yes, you can. You are free. But for me, I feel that this formula here, writing my function using the unit step function, will save maybe 3 minutes. So I'm going to do that. And don't worry, in your exam, if you can't guess immediately which is the suitable technique you have to use in this problem, please do what you find easier for you. So don't lose more than 1 minute to decide which method is more suitable to solve this problem. So for me, this is my f. This is my f of t. I'm going to write it using this formula down here. So let me use another color to determine the g and the Omar Salam. Omar here? Can you help Omar?
Yes, hello.
Your GT, please. Where is your GT? I'm going to apply this rule now, Omar.
Sin t.
Yes, GT equal sin t. Your A, please. Your A.
الباي يا دكتور
Pi. Your H.
كالزيرو.
0. Now, let us go back and plug in, please. Help me now to write the formula for the function f. So what should I write here?
piecewise
Yes, the formula here. I need this formula.
يبقى
Instead
sin
of
t
G,
minus
sin t minus
sin t
sin t times what?
ميو اللي هي t minus a
Where is A?
0 باي سوري
By plus your H,
which is 0
0. 0 times anything, it's 0. No need to write the answer. Okay. Yes. So yes, thank you, Omar. My differential equation now, it will be y prime. So sorry here, y prime plus 2y equal all those sin t minus sin t times u of t minus pi. Now I'm going to apply the Laplace transform for all terms. So first step, Laplace of y prime plus 2 Laplace of y equal Laplace of sin t minus Laplace of this product sin of t times u of t minus pi. Muhammad Urabi, could you please help? Do you remember, Muhammad Urabi, the rule of Laplace y prime? Or do you have your cheat sheet? Urabi, can you hear? Yes. Do you have the rule? What do you think, Muhammad?
So sy capital
S y capital, okay, great, minus y small of 0. Continue, please. Plus 2. What about of Laplace y small?
sy capital also.
No, it is only y capital. Laplace of y small, it is y capital, okay? Equal Laplace of sine. Do you remember the rule of Laplace of sine? You can use your cheat sheet. Laplace of sine t. Do you remember?
1 over s squared minus 1.
Minus? Minus? Or plus?
Yes.
No, it is a plus. The shine, it is minus. The sign, it is a plus. So we'll check it, Muhammad, please. Minus. Yeah. How to find Laplace of this product? What do you think, Muhammad? Can I use this rule? Notice now. Can I use this rule here? GT times ut minus a. So let us together decide which function it is your GT. So let me use another color now to write the GT. So for this, your GT is what?
The sin t.
The sin t. Your A is what?
Pi.
By. And also notice here you need GT plus A. So you have to determine your GT plus A, please. GT plus A is what? Your GT plus A is
Sin
what?
t plus pi.
The sin t plus pi. Great. Great. I understand. Let me go back to yellow now and continue writing the solution. 1 minute. So minus, you said, Professor, you have to apply the rule down. So it is e to the negative as pi s times Laplace transform of gt plus a, and you said it is sin t plus pi. Yes, I understand. Now the y0 is 0, cancel it out and take the y common factor. Thank you, Muhammad. Y common factor, y capital. So I have s plus 2
Doctor, I
equal.
don't understand
Yes, I will repeat it. I will repeat it. 1 minute, please. S squared plus 1 here. So I'm going to re-explain how to find. 1 minute, please. So how to find the Laplace of this product. I have a product here. For me, in the previous lecture, I studied how to find Laplace transform of our product between two functions. One of them is exponential. No, now I don't have exponential. In today's lecture, I studied how to find Laplace transform of our product between two functions. One of them is the unit step. Here the rule. To apply this rule, you have to determine your G. Where is your G here? Where is your G? Omar, where is your G?
Yes يا دكتور.
It's sine.
الساين
Yes. Where is your A? Where is your A?
باي.
Pi. If your GT, it is sine T. Because here you have GT plus A, so I'm going to find GT plus A. If the GT is only sine, so GT plus A, it will be what? What do you think, Omar?
ساين تي بلس باي.
Yes, because your A is Y. Now, I'm going to write the answer here. I'm going to write the answer here up. First of all, you need the exponential, so I wrote the exponential. And you need Laplace of GT plus A, and your GT plus A is given the sign, so I wrote it here. Is it clear now, Omar?
Yes يا دكتور. Yes.
Yeah, great. Now, minus the exponential. Yeah, I have a problem now. How to find Laplace of sine T plus pi? How to find sine, Laplace sine T plus pi? Or do we have a rule similar to this in our table? Laplace of sine T plus pi.
I
What do you
think
think?
اللي هي sin t times cosine pi.
Great, excellent. So Mahmoud suggest an idea. Maybe I will use it or no. So he said, Professor, I have a rule which says sine of x plus y is given to be sine x cosine y plus cosine x sine y. You are right. In the previous section also, when students suggest this, and also another one suggests the easiest rule. It is a trigonometric rule, but it is easier than this, and I can use it now. What do you think? Anyone, if you remember? If you have a plus pi.
تبقى sin t cosine pi plus sin pi cosine t.
Yes, this rule, yes. But I have easier one. Yes. Who need to
You
speak?
can say that sine t plus pi equals negative sine t.
Yes, great. Great. I have a rule also. Sine of t plus pi is given to be, in our trigonometric rules, is given to be negative. So it is Laplace of, I'm so sorry. Just 1 minute. Is given to be Laplace of negative sine of t. It's a rule. Take the negative out. Take the negative out. Yes, let me take the negative out. So I have y s plus 2 equal 1 over s squared plus 1 plus e to the negative by s times Laplace of sine. I know it is 1 over s squared plus 1. Now you need to find y capital by dividing all terms by its coefficients. So it will be 1 over s plus 2 times s squared plus 1 plus e to the negative by s times 1 over s plus 2 and s squared plus 1. Do you remember the steps after that? After getting y capital, it is our second step. Third step, do you remember what is the third step? Bailey, do you remember the third step? After getting y
Not sure.
capital. Yeah. After getting y capital, third step is to take inverse Laplace for all of them. So you need to find Laplace inverse of y capital. Is given to be Laplace inverse of the first fraction. I don't have a space, so I'm not going to write it here, okay? Plus Laplace inverse of the exponential, negative pi s, times the same fraction. 1 divided, here something, and here divided the same thing. So now, Laplace inverse of y capital, it is y of t. Laplace inverse of this fraction, I'm going to black slide to find it, okay? So in the coming slide, I'm going to find the Laplace inverse of this fraction. Let me use the yellow. So I need to find Laplace inverse of 1 over s plus 2 squared plus, I forget, unfortunately. S plus 2 is squared plus 1. S squared plus 1. Who can help to find inverse Laplace of this fraction?
Partial fractions.
Partial fractions, yes, great. So here I'm going to use the blue maybe to do the partial fraction for this fraction. So here S plus 2, here is squared plus 1 equal A over S plus B S plus C over S squared plus 1. Am I right by this two fractions?
Yes.
Now look, I'm trying to find them quickly.
دكتور
To
مش
find
هي S plus 2 يعني A
the
over
first
S
one,
plus
I'm sorry. Yes, Abdurrahman, I'm sorry. Here S plus 2, you are right. Now to find A quickly. So here I'm going to find A. I'm going to multiply this equation by the denominator of A and let S equal -2. So if I multiply by S and let S equal 2, this will be cancelled out. Here the S is -2 squared 4 plus 1, it's 5. So here, so I have, just 1 minute, 1 over 5 equal. I cancel out this because I divided by it. And this term will be 0 because you multiplied by S plus 2. So I found A. Now to find B, by the way, you are free. You can use my technique or your technique. Make them the same denominator, equate between the coefficients, you are free. Now for me to find B, look what I'm going to do. I'm going to multiply my equation by S. So here S, here S, here S squared, here S. Okay? And I'm going to let the S tends to infinity. Okay? So here, what I need to write, just 1 minute, I'm going to let my S tends to infinity. So if the S tends to infinity and S tends to infinity, could you please tell me the answer of this fraction if the S is tends to infinity? If you multiply by S and let S tends to infinity, so this fraction, it will be what? If your S infinity. It's very easy for you. Here you have only S down, you have S to the power 3. Your denominator has power greater than the numerator, so your answer is 0. So 0 equal. Here AS divided S plus 2. When S tends to infinity, take the coefficient up, divide coefficient down, so it's A. Plus S squared here and S squared, the coefficient and coefficient, so it's B. So my B equal -1 over 5. You can find it using another technique. For me to find C, I'm going to choose the S to be 0. I'm free, and you are free also. If the S is 0, so here, by the way, no S. S is 0, so here 2 and 1, 1 over 2. S is 0, so I have A over 2, plus S is 0, so I have C over 1. So my C, it is half minus 1 over 10. So here it will be, I'll multiply by 5. So 4 over 10, which is 4 over 10, it is 2 over 5. I found quickly those constants. This is my C. So now to find inverse Laplace for the fraction up, I'm going to go back to the yellow and write here. 1 minute. So this, it will be the inverse Laplace of instead of A, you have 1 over 5 all divided S plus 2 plus Laplace inverse of the B, it is -1 over 5 S, okay, plus the C, which is 2 over 5, okay, divided by S squared plus 1. Am I right here? Yes. I'm sorry, maybe I need to write it, but I think you can understand. So equal 1 over 5 is a number. Laplace inverse of 1 over S plus 2. Yeah, how to find Laplace inverse of the second fraction? This one.
We split it.
Yes, you are right. So -1 over 5, I take it out and split into two fractions, s over s squared plus 1 plus 2 over 5. 2 over 5 Laplace inverse of 1 over s squared plus 1. Yeah. Now, can anyone of you remember Laplace inverse of this function?
e to the power of negative 12.
E to the power negative 2t, you are right, minus 1 over 5. What do you think about this?
Cosine t.
Cosine t, great. What do you think about this?
Sine.
Sine, right, sine of t. So we found the Laplace inverse of the first fraction. Let me go back to check the second fraction. Where is the second fraction? This one. It is this one here. Where's my pen? Where's my pen? Here, my pen. So the second fraction is this one. This one. I'm going to take it to the new slide now. So here, I'm going to write here. Let me use another color, maybe it's better. So now you need to find the Laplace inverse of e to the negative by s. Am I right? It is by s. Yes, by s times 1 over s plus 1. No, it is s plus 2, s squared plus 1. Yeah. You have a product here between two functions and you need to find do we have a rule similar to this? Yes, it is this one. It is this one. Notice here you have e to the negative and you have e to the negative times fs. Where is your fs now? Where is your fs? Where is your fs?
The fraction.
The fraction. This is my fs. This it is my f capital of s. I have here, I have to write the f small. If you know f capital, how to find f small? This is my question. How to find f small?
Laplace inverse.
Laplace inverse of f capital. Any question here? Is it clear? I'm going to apply this rule now. Yes. And after finding f of t, I'm going to find f of t minus a. But let me, with you, try to find f of t. Can anyone of you tell me where is the f of t? Or how to find f of t? Or can I find inverse of this function? What do you think?
Yes.
Where?
جبناه.
What?
اللي هو last year yellow line.
Yes, it is here. Notice that this fraction here in red, this fraction, it's similar to this one. So you found this answer. So the answer here is given by the last line here, Laplace inverse of the same fraction. So it is, let me write it, 1 over 5, e to the negative 2t, minus 1 over 5, cosine t, plus 2 over 5, sine t. Professor, why do you need f small of t? Because here the rule, I'm trying to apply this rule. This rule need f small. And by the way, it need also a. Where is the a? Where is my a? Where is my a?
Hi.
Pi. Great. So here I wrote the rules. I have only to find now f of t minus pi. Am I right? So I'm going to write here, I'm sorry for my writing. F of t minus pi. Who will help to find f of t minus pi? From where, Professor? From ft. You have ft here. Give me ft of minus pi, please, quickly. So it will be what?
1 over 5
1 over 5?
for negative 2, bracket 2 minus
T,
5.
t minus pi, great.
Minus
So you will replace each t here by t minus pi. Minus 1 over 5. Cosine t minus pi
plus 2 over 5 sine t minus
plus 2 over 5 sine 2 minus pi. Now I'm going back to green to write the answer of my Laplace inverse. The rule said you need to write f of t minus pi. So let me write f of t minus pi. which I found here, 1 over 5, e to the negative 2 t minus pi, negative 1 over 5, here minus, cosine of t minus pi, plus 2 over 5, sine of t minus pi. You need to multiply your answer, this one, by the unit step function. Notice I'm trying to apply the rule. Please focus with the rule. U of t minus pi. So we finished by finding this answer, the white here, the green and the yellow. This is the solution of my differential equation, because we need to find inverse of this and inverse of this, and we did now. What do you think? By the way, for me, I believe that if the students didn't use the rules and didn't memorize or write them in the cheat sheet, so he can't at all find the Laplace transform easy. Okay? So do you have any question now? No questions. Let me go. If you have any question, I can help. Now, last thing which I need to explain, notice now my function is given in 3 formulas, not only 2 formulas. We studied if my function has 2 formulas, but now if my function has 3 formulas. How to write my function now as a unit step function formula? You need to write this formula on your cheat sheet. For me, to be honest, I prefer to deal with only 2 formulas. But because I have some problems in the textbook and the web assign has 3 formulas, so we need to discuss together how to write any function using if the function is given in 3 formulas, how to write it as a formula using unit step function. Okay, here you have one function, this one, and I need you to find Laplace transform of it. How to find Laplace transform of it? Maybe one student will say, Professor, I will integrate and separate my integral into 3 integrals. Well, you are free, and integrate by part, you are free, no problem for me. One another student will say, Professor, I will use the formula of unit step function. Then I will apply the shifting theorem. You can do that. Okay, so please try to do this and send it to me by WhatsApp. Find Laplace transform of this. And by the way, you are free. And I advise the students, if you have time, try to do it using 2 different methods. The first one as an integral, second one using the unit step function formula. Okay? I'm not sure how many minutes do we have? I think we've finished. Yes, we have 10 minutes. So if you don't have any question, we can start solving the worksheet. Anyone of you? Yes.
All the questions here in this lecture, if he asks about an IVP, it's going to be a piecewise function, right?
In this lecture, but in the exam, no. Okay?
Oh, okay.
Maybe in the exam you have similar to this one, which we did now. Or no, I'm not sure. I don't know. But you have to remember in the exam, if I have a function similar to this, a piecewise function, so I need to use the unit step function. So do you want me to share with you now the worksheet? Ready?
Okay.
Yeah. So now I have number 1 and number 2. Maybe I can finish with you number 1 and number 2. We can do it at 1 o'clock if you have any difficulties. So together now, let us try to find the Laplace transform of this. So it's a product between 2 functions. One of them is the unit. My cheat sheet, Laplace transform of gt. Actually, me as you, I love my cheat sheet. And by the way, when I was a student, what I need to say that the course is easy, or this university maybe deal with you easily, because when I was a student, no cheat sheet at all. You have to memorize all the rules. Now, the difficulties, I think, for the students who believe that it's enough to write the formulas in my cheat sheet and no need to practice how to use them. Unfortunately, at that time, you can't use them also in the exam. Let me continue now. Laplace transform of g of t times unit step of t minus a is given to be e to the negative as times Laplace transform of my gt plus a. In details, if I need to do this problem, first of all, let me use the blue. Where is your a? Using the problem here. Where is your a, please?
Pi.
A equal pi. Where is your g?
932.
So g of t, it is sine 3t. Now I need you to tell me your gt plus a plus pi, a or pi. Am I right? Plus pi. Professor, why always you try to find gt and gt plus pi or plus a? Because I have here. I need it. So I'm trying to prepare myself to apply this rule. Can you help? So it is sine of 3 bracket t plus pi. Now I'm going to apply the rule. The rule said you have to write the exponential. So it is exponential. A is pi s times Laplace of the gt plus a, which is sine 3t. It is 3t or 3, I'm so sorry. 3t plus 3 pi. How to find Laplace transform of this sign? What do you think? How to find it? Laplace of this. By the way, 3 pi, it is the same as pi because the function sign is periodic with period 2 pi. So 3 pi, it is 2 pi and pi. Cancel out 2 pi, so you have only pi. The sign of angle plus pi, it is negative of the sign of the angle. So it is negative here, Laplace of sine 3t. For me, my cheat sheet said that I have the following for the sine: 3 divided s squared plus 9. Is it clear?
دكتور
Yes, عبد الرحمن.
can you please say the rule بتاعت الانجل دي اللي هي when we have sine and زي ما عملنا في الاكزامبل احنا they said there's a rule بنستخدمها لما يكون في sine مثلا t and pi.
Yes, I understand. You want me to say the sign of x plus y, it is what?
لا
This one?
بس understand لما يكون يعني زي في الاكزامبل بتاعت الليكتشر كانت x و pi بعدين قلنا ان هي
Yes.
negative 1.
Yes. If you have, so now my question, x plus pi, in which quadrant it will be? It will be in the third quadrant, and in the third quadrant, my sign is negative. So it is negative sine x. Also, if you have sine of x plus 3 pi, which is the same of sine x plus pi plus 2 pi. The sine is periodic function, no need to write its period. So I have only sine x plus pi, which is given to be the same like this, negative sine x. This is your question, Abdurrahman?
Yes, doctor, thank you.
Yes. Other questions, or can I do number B now? Let us together do number B. Yeah, I need to find Laplace inverse of this. I remember the formula. Don't forget that your professor said if you didn't practice how to use the rules of Laplace transform, so the chapter of Laplace transform will be very difficult. I remember the rule, Laplace of e to the negative as times f capital of s is given to be what? F of t minus a times u of t minus a, such that f of t small, it is the inverse Laplace of your f capital of s. My question, where is your f capital of s? Where is your f capital of s?
1 over s times s plus 5.
1 over s plus 5, you are right. Now I need to find f small of t by taking its Laplace inverse of this fraction, which is 1 over s plus 5. How to find the inverse of this fraction? How to find the inverse of this fraction?
Partial fractions.
Partial fractions. So I'm going to write here s plus 5, which equal 1 over s, not 1a plus b over s plus 5. Quickly, If I need to find A, I'm going to multiply by S and let my S equal 0. So I have 1 over 5 equal A. To find B, I'm going to multiply by its denominator and let the S equal -5. So -1 over 5 equal B. Okay. So I have now here, I have Laplace inverse of the first function, which is 1 over 5 over S, plus Laplace inverse of -1 over 5 over S plus 5. This, it will be 1 over 5 times 1. Okay? And this, it will be -1 over 5. What about if this S plus
E power
1 over S?
-5t.
Yes, e to the -5t, you are right. This is your f of t. The rule need f of t minus a. My aim, here my aim, you have to focus and look to this. So I'm going to write here f of t minus a. What is my a? What is my a? I forget the a. What is your a?
2.
2. Here the a, here. So my a is 2. So minus 2 is given by 1 over 5, it's a number, minus 1 over 5, e to the -5 bracket t minus 2. This is f of t minus 2. Now the final answer, I'm going to write the formula here down. So Laplace inverse of this, it will be f of t minus a, which you found it to be 1 over 5 minus 1 over 5 e to the -5 of t minus 2, t minus 2, times the unit step u of t, and your a is 2. Here you need the bracket. This is the Laplace inverse of this function. Is it clear? So do you have any question? We can meet at 1 o'clock to do the problem number 2 if you have any difficulties. If you have any question, I can help. If no questions, so goodbye.
دكتور مثلا حاجه في ويب اساين يعني
You have
هو
a
مش
que-
سؤال هو مش سؤال هو بس الاساينمنت اللي يعني الاساينمنت اللي هي بتاعت
Yes, yeah. One of your colleagues told me that maybe there is
الميعاد
something.
بس
Yeah.
يعني it's due
I will
today
check. Yes, I will check.
Okay, thank you doctor. Thank you.
Welcome. Other students, do you have any question?
Thank you, doctor.
Welcome, Mahmoud. Mahmoud here. Yes. So we can meet at 1 o'clock if you have any question. Islam, do you have any question?
What about the grades?
Tomorrow, inshallah. Today or maybe today at night or tomorrow, inshallah.
Okay, thank you.
Welcome, Islam. So, yes, sir.
Doctor, one of my friends is was going to take differential equations, but the course is all of it is TBA. I want to ask you, Doctor, when will you give the differential equations next semester?
I think on Saturday.
Saturday, which time?
Both of them. That there are 2 sections on Saturday and Tuesday. I'm going to teach both of them.
Okay, thank you so much, Doctor.
Welcome, Sam. Bye bye, Sam.